Okay, so let's see how smart you guys are. See if you guys remember this stuff. All right, what goes here? 1/2. Root 2 over 2. Root 3 over 2. 1/2. Square root of 3 over 2. All right, and then sine is positive in the top two. Cosine's positive in the right two. Tangent's positive in the first and third. And then what is the sine of 0 degrees? 0, 1, 0, -1, 1, 0, -1, 0, 0. All right. With this information, right, we should be able to solve questions like, what is the sine of 240 degrees? Right? No calculator. Next week, you're going to take a quiz in here. Tuesday or Wednesday. We'll see how it goes. Sounds good. Okay. Sine of 240. No calculator. There's going to be a quiz. It's going to be a 2-part quiz. Part 1, no calculator, just a pencil. I'm going to give you a sheet of paper. It's going to have a bunch of these problems on there. You're going to solve them all. And then you're going to turn it in. And then I'm going to give you a part B. And then you can use a calculator. So, sine of 240. What's my reference angle? 60. What's sine of 60? Square root of 3 over 2. What quadrant is a 240 degree angle in? Third. Sine in the third quadrant is negative. Easy. Remember, the reference angle is always what is that acute angle formed with the x-axis. So how you get it varies by quadrant. In this case, you're basically saying, yeah, how far past 180? But if it was cosine of 120, well, 120 is now in the second quadrant, right? But what is that little acute angle formed with the x-axis? 60 degrees in this case, yes? How'd you get it? 180 minus instead of that, right? So it's going to vary quadrant by quadrant how you get there. But as long as you remember, the reference angle is just the little acute angle formed with the x-axis, you can generally figure it out. Yes? What's cosine of 60? 1 over 2. Second quadrant, cosine is? Negative. Now, once in a while, you run into problems like, what is the tangent of negative 120 degrees? Well, what does the negative angle just mean? It means you're going down. It does not mean this answer is going to be positive or negative. The only thing that negative means is I'm going that way around the circle. Now, a negative 120 would be down here. Yes? What is that little acute angle formed with the x-axis here? 60. What's tangent of 60? Root 3. Right? Now, the negative did affect the quadrant. What quadrant did I end up in, though? Third quadrant. Is tangent positive or negative in the third quadrant? It is positive. So just because you see a negative angle does not mean the answer is negative or positive. The only thing the negative means is we're going around the circle in the other direction. Make sense? Are we good with this? Easy so far. Now, the only difference between what we're doing yesterday and what we're doing today is I'm going to ask you, what is the tangent of 125 degrees?
You don't get a good number of times.
What do you mean? What do you mean I don't get a good number? It's not one of my specials. This, we memorize these. We memorize our 30s, our 45s, our 60s because they're special. They're common. We use them all the time. Now, I know approximately what this answer is going to be because I know that 120, which is pretty close to 125, is approximately the square root of 3, right? And I can, if you want to put it as a decimal, the square root of 3 is roughly 1.73. I'll bet you the answer to this is really close to negative 1.73. Agreed? Yeah. Now, why did I say negative?
Because it's not the second quadrant.
It's in the second quadrant, right? Because tangent's negative in the second quadrant. So I can use my specials to also estimate what the answer should be. I know what the answer should be close to. Now the question is, how do I actually calculate this? Because I'm not going to have a table where I can memorize everything. Like, that's just not possible. So I need a way to do this. Step 1, we grab a calculator. If you don't have a calculator, grab one. Here is the problem we are doing. Now, the second you grab a calculator, yes. Here's why. I'm about to show you. The absolute first thing you have to do, you have to check your mode. Now, all scientific calculators have the ability to do radian measurements and degree measurements. You have to check your mode. I'm telling you right now, this is going to happen to at least one person in this class some point this year. There's going to be times we want to be in radian mode. There's going to be times we want to be in degree mode. There's going to be one test where sometimes you're going to want to be in degrees, sometimes you're going to be in radian. You're going to change it as you go. Sometimes there's going to be tests where you want to be in radian or degree mode the whole time. There's going to be someone in this class that this happens to. You're going to take an entire quiz or an entire test, and you're going to get to the end, and you're either going to go, oh my gosh, I did this whole test in radian mode, and I have to start over because all of these answers are wrong. Or you're going to realize it right at the, or you're just not even going to realize it, and you're going to turn your test in, and I'm going to mark them all wrong. Sorry, it's just wrong answers. You have to make sure you know how to switch your mode, and you have to be careful of how you do that. Now, on these calculators, it's very simple. You press the mode button. The third one down, it gives you a toggle switch between radian or degree. You put it on degree, you press enter, and you're in degree mode. If you want it in radian mode, you put it enter on radian. Yes?
I did that, and I got 1.42.
Good.
Negative 1.4.
Yeah, negative.
Good. That's about what we thought it would be. It should be about 1.7, right? 1.4 is pretty close.
Okay, wait.
Now, is there anybody, first off, that does not know how? Because every calculator is a little different. Every calculator is a little bit different. If you have one of these, it's right next to the second button. There's a DRG button. You press the DRG, and you could just move the arrows over to radians and degrees. Casio's can be a little weird. Did you get yours?
No, I did, but I wanted to really ask you something. I did it when it was in the other mode, the radian.
Radian? Yes.
But I put like the degree symbol by it, and I got the right answer.
That's a long way of doing it. It will convert it. It's weird. I don't recommend doing that because it's a pain in the butt. Did you get yours? What kind do you have? Oh, it's Casio? I'll have to look at that one. Casios are weird. I'll look at that one in a little bit. Or pass it up and I'll try to work on it. So with this one, all I'm going to do to find the tangent of 125 degrees. Number one, make sure I'm in degree mode. Tangent, 125. Bam, the answer is negative 1.48, which, you know, it's a little off of what we kind of expected, but not too far. With this one, is it in the menu? Oh, is it in the setup?
It's so loud.
Yeah, setup. Hit shift menu, and then it's in there. Oh, pass that back. Shift, hit shift menu, and it's like the 5th or 6th one down. It says, it's right at the bottom of the screen right now, it says radian, then you can change it. Okay? All right, are we good so far? So, how would you do this? How would I type in the cosine of 132 degrees, 18 minutes, 41 seconds? Number one, what mode should I be in? Which is it, radian or degree?
Degree.
How would you read that? 132 degrees. So it better be in degrees. So make sure you're in degree mode. And then you just type in cosine of 132. Hit that angle menu. Hit that 0, or the degree symbol. And then 18. Go back to that angle menu. Get number 2, the minutes. With this, what's the easy way to get the seconds? Alpha plus. Bam. And you can put that in as is. Why is it giving me a negative angle measurement? Or why is it giving me a negative decimal here?
Cosine of 132.
Because 132 is in the second quadrant. That makes sense. Yes. No, those you don't. Because you're typing in the degree symbol, it doesn't really matter if you're in degree mode, but I would recommend, just to be safe, you're always in degree mode with those kind of questions. Okay? Are we good so far? Yes? Okay. How would I do this? Sine of 11 pi over 13. That's a radian measure. Now, there's 2 ways you can do this. If you put your calculator in radian mode. So, put your calculator in radian mode. You type it in as is. You press the sine button. You go 11. You go get your pi. You divide that by 13. Bingo, bango. You have the right answer. But you have to be in radian mode to do that. Could I do it and leave it in degree mode? It is possible, but you have to type it in differently. I'm going to go sine of 11 what? Times 180. Divide by 13. Basically, let the calculator convert it to degree.
No, you don't need it.
I don't need it. Order of operations. Okay? And you can get the same answer. It really does not matter if you do it in degree mode or radian mode. But if you do it in degree mode, you have to remember to replace that pi with 180. Fair enough? Degree is easy. Radian's easy. So far, so good?
Anything with pi is going to be radian, and then everything else is going to be degree.
If you want to type it in with a pi symbol, yes. If you want to type it in with a 180, you're over here. Now, SAT, you could run into what is the cosine of 4.173 radians. You can do it as a decimal. You just type it in. What mode would your calculator need to be in? Radian mode. So just put your calculator in radian mode, type it in, cosine of 4.173. Just make sure you're in radian mode. Make sense? Easy so far. How about this, though?
You don't know how to do that.
But you do. You do know how to do that.
Oh,
And
it's
here's
the
why.
thing.
In this class, earlier this year, the very first time I introduced secant, I wrote on the board, secant of any angle equals, what was the first thing I wrote down?
1 over the thing.
1 over the cosine of a secant. Your calculator does not have a secant button on it. It doesn't. The only calculator I've ever seen that has a secant button on it is a TI-89. I've never seen another calculator that has one. There might be one out there. I've just never seen it. Don't even bother looking for a secant button. It's not in there. The only way your calculator can do this, and it can do it, what you have to type in is simply 1 divided by the cosine of 218, making sure my calculator is in degree mode. That is how you're going to type that in.
Can you give us some positive ones?
Sure.
Almost every single one you do.
I'm just picking random numbers off the top of my head. Huh?
I said almost.
Oh, almost. Are we good so far? So how would I type in what is the cosecant of 5 pi over 6? How would I type that in? And do I need to type that one in?
Yeah.
That's one of your specials.
No, it's
That's a 30-degree angle.
so this is
It's 2. I'll bet you the answer here is 2.
Yep.
How did I get that in my head?
how do you do it?
Special angle.
Cosecant is 30. So that's sine of 30, right? Sine of 30 is a half. I know the reciprocal of that's going to be 2. Now, if you didn't realize that, what could I type in my calculator? 1 divided by sine of 5 times 180. Why am I doing times 180?
Because you're not in radian.
Because I'm in degree mode, right? If I wanted to be in radian, I could just put a pi there instead of a 180. But you have to make sure you do that 1 divided by anytime you're dealing with a reciprocal function. Are we good so far? At this point, with a calculator, I should be able to give you any 6 trig function, sine, cosine, tangent, cosecant, secant, cotangent, of any angle in degree or in radian, and you tell me what the decimal value equals. Easy? All right. But what about these? In the homework the other day, I gave you a question that said this. When does sine of theta equals negative 1/2? Gave you a question just like this. How many answers did it have? It had 2. Why did it have 2? Well, remember, what we're doing here is this. We have this fun drawing, right? We're going round and round the circle we go. The sine value is equal to the y value, right? Or I'll just move. So, whatever. So we're going to go edit, display, make that bigger so you guys can read that, increase. Okay, so we have my sine value is 0.73, right? Where is it on this graph? Is it going to equal negative 1/2? Well, sine's down here. There's a spot over here where it equals negative 1/2. Is there another spot where it's going to equal negative 1/2? It's going to be over there somewhere, right? So there's 2 answers to this. How did I solve? Excuse me. How did I solve this one? Well, I knew there had to be 2 answers. One in the third, one in the fourth quadrant, didn't I? Because when is sine negative? I also knew my reference angle. What was my reference angle? 30 degrees. What's a 30 in the third? 210. What's a 30 in the fourth? 330. So there was my 2 answers. Yes? Now, This is the same kind of deal. There's going to be how many answers? There's going to be 2 answers to this. What 2 quadrants am I looking for answers in? First and second. Why first and second in this case? Because that's a positive number. I need to know that going in. We're going to use our calculator. Now, there's a big problem with these calculators, with all calculators. I will teach you why this is all true in the very near future, but for right now, all you need to know is about the problem. The problem is calculators cannot handle questions that have multiple answers. They just can't. They have to be able to spit out one answer. They just can't handle multiple answers. They can't give you both. This is not going to give you both. It's going to give you one of them. Now, how do we get rid of that sign? How do I get the angle by itself? Nope. Well, you're on the right track. The reason why he said divide by is he was thinking something like this. I need to get the x by itself, right? How do you get rid of the 2? Now, what you're doing is you're doing something that's going to cancel the 2, right? You're dividing by 2. We need to do the same kind of thing. But the only thing that's going to cancel that sign is what we call the inverse sign. Okay? That's the inverse button. Now, where does the inverse button come into play? Where is the inverse button on here? It's the second version of the sign button. Now, when you type that in, what kind of answer is it going to spit out? What kind of answers are we looking for here? The angle measurements. We're looking for the angle measurements. There's a big difference between solving problems like these of what is the cosine of an angle. The input is the angle. The output is the decimal. When we do the inverse, what's the input? The decimal. What's the output? The angle measurements, right? So we're doing it backwards. When I press enter on this, it tells me that one of my answers is 37.8 degrees. It's not going to give you the other angle. You got to come up with that. Now, the way you come up with it is what other quadrant do I need to be in? Second quadrant. It has to have the same reference angle, right? So, if this is 37 degrees, this is 37 degrees, 180 minus 37 in this case, 180 minus that angle, and your other answer is 142. So the way you do it, inverse sine, it's going to give you one answer. You need to know what other quadrant it goes to. In this case, it's second, so you go 180 minus. If it was a problem like, let's say I want to do this. Tangent of what angle equals 2.71? What buttons am I going to hit? Second tangent, inverse tangent of 2.71. Now, that's going to give me one answer. One answer is 69.75 degrees. Now, that answer is in the first quadrant, which makes sense. That's where one of the quadrants where tangent's positive. What's the other quadrant where tangent's positive? Third. How do I get to the third quadrant? 180 plus the reference angle. So now, instead of doing 180 minus, I do that answer plus 180, and there's my other angle. Are you going to do the same thing on every problem? No. Because it's going to vary every single question. Sometimes you're going to want first and third quadrant. Sometimes it's first and second. Sometimes it's first and fourth. Now the hardest one to me is this one. What two quadrants do I need to be in here? When is cosine negative? 2 and 3. Now, when you type that in your calculator, what's the first buttons I'm going to hit? Inverse cosine, second cosine, negative 0.712. It's going to give me an answer. It's going to say one answer is 135 degrees. Okay? So that means I know this answer is 135 degrees. How do I get my third quadrant answer then? What do I not know right now? I don't know the reference angle. Before, I knew the reference angle, didn't I? Because it gave me an answer in the first quadrant. And an answer in the first quadrant is always the reference angle, right? The problem is in this case, I don't know the reference angle. I just know the answer. So how do I find the little reference angle here?
180 minus that.
So in this case, I'm going to do 180 minus that. Dang it. 180. I don't know why it works better when I stand over here. 180 minus that. Okay. So that's 44 degrees, which means this has to be 44 degrees. So how do I find the third quadrant answer? 180 plus. You are going to have to do that every single time you do an inverse cosine of a negative. Because with an inverse cosine of a negative, it's the second and the third quadrant. Okay? You're going to ask about inverse sine of a negative. Let me show you that one. What are you going to ask? I'll get there. I'm baby stepping there. Sine, cosine, tangent first. So we did sine, cosine, tangent first, right? Then I talked about the secants and the cosecants, right? So yeah, we're doing sine, cosine, tangent first of the inverses. Yes, we're going to do the cosecants next. But I want to show you this one first. What happens when I get a negative inverse sign here? Something weird happens. I will teach you why this happens later on, but right now I just need you to see what happens. Inverse sine of negative 0.814. What kind of answer does it give me? A negative angle. I don't want any negative angles for final answers. But what two quadrants was I supposed to be looking for here? Third and fourth. Why the calculator does this, I will teach you this later. But did it give me one of the answers? Yes. Where's a negative 54 degree angle? It's right there. I just personally don't want you to give me a negative angle as one of your answers. So how do I find the positive version of that third degree, or that fourth degree? Add 360. So all you're going to do is add 360. So one of your answers ends up being 305.5. I just don't want the negative 54. Now, the good news is, do I know my reference angle? My reference angle is 54, isn't it? So how do I get this third quadrant angle? 180 plus the 54. The way I would do it is I would do 180 minus, go up and grab the negative, because minusing a negative is the same as adding. That's how I personally would type that in. And there is your two answers. Does that make sense? Yes? Every answer you give me right now has to be between 0 and 360. So if your calculator spits out a negative, and it will, it'll spit out a negative anytime you do the inverse sine of a negative and inverse tangent of a negative. It's going to spit out a negative angle. I'll teach you why later. I don't want those answers. All you got to do is find the coterminal version, the positive version. Add 360. Then find what other quadrant that you need to be in. The good news about those, even though it didn't give me an answer I could use, what did it really give me? it gave me the reference angle. So that's a good thing, right? The only one that it doesn't give me the reference angle is when I do the inverse cosine of a negative. And that's because we're in the left two quadrants. So you can't get a reference angle by going up or down real easy. It's going to give me an answer. I have to find the reference angle before I can use it to find my other answer. So far, so good. So at this point, right now, you should be able to find sine, cosine, tangent, cosecant, secant, cotangent of any angle. I should be able to find the cotangent of 17 pi over 13. That should not be a difficult, or cosine of that. I should be able to find the cotangent of 218 degrees. Are we good with those two questions? This one you just type it in as is if you're in radian mode, or what do you replace pi with? 180. Put it in degree mode. This one, what do I type in my calculator? 1 over tangent of 218 degrees. Yes? We also should be able to find the sine, cosine, tangent of what angle equals a decimal. What do I type in my calculator? Inverse sine. Whenever you're looking for the angle measurement, you're going to use an inverse. How many answers are you looking for? 2 answers. In this case, I'd need one in the first quadrant and one in the second quadrant. Make sense? That's a positive number. When is sine positive? That's how I know what quadrants to be in. Okay? Are we good so far? There's only what's left. So now I've got to be able to do these. Now, what does cosecant of theta equal? No, it's the reciprocal of sine. Now, you're not going to have to do this every time. Does everybody see the substitution I just made? Yeah. Cosecant is the same as this, right? Just make that substitution. Think of this like a butterfly problem. What would you end up doing here? Wouldn't you end up doing 1 divided by the 2.17? Because you do 1 times 1, then you divide by the 2.17.
If you just type it in regular 1 divided by the sine.
No. What you're actually going to type in your calculator, whenever you do an inverse, whenever you're doing an inverse, looking for the angle, you have to do an inverse. If you're dealing with a reciprocal function, you must take a reciprocal. You're going to do a 1 divided by. If you're doing an inverse of a reciprocal, the inverse goes on the inside. You do the inverse sine of the reciprocal of 2.17. So here's how I remember this. Here's an easy way to remember this. If you are dealing with a reciprocal function, you must take a reciprocal. This one, you do the reciprocal on the outside. If you're dealing with an inverse, if I have to take the inverse of that reciprocal, the reciprocal goes on the inside. How many answers are there going to be to this? 2. From there, you solve it the rest. The same.
So that one is just 1 answer?
This is just 1 decimal answer. This is 2 angle measurement answers. If you're dealing with a reciprocal function, you must take a reciprocal. I'm taking a reciprocal in both of these problems, aren't I? If you're dealing with an inverse, the reciprocal must go on the inside. To me, that's the easiest way to try to remember that. Inverse, inside. When do you take a reciprocal? Only if you're dealing with a reciprocal function, right? If you're dealing with a reciprocal function, you must take an inverse. If you're dealing with a reciprocal function, you must take a reciprocal. If it's inverse, it goes on the inside. Inverse, inside. Inverse, inside. Are we good with these for now? Let's try. We'll do a bunch of problems in class on Monday.